Today we'll be talking about the web, how it works, what are requests, responses, and looking at some real examples. One main protocol the web uses is the HTTP protocol. Now if you're not familiar, you already are using HTTP and in fact HTTPS in that regard. Let's take a look at this example. This is you want to visit YouTube. You, as the client, send out a request for YouTube's URL to Google's web server. The server processes the URL and gives back the HTML, CSS, JavaScript, along with the other assets of course, to construct the YouTube web page for you. Now what is HTTP and what does it stand for? Hypertext Transform Protocol. The purpose of HTTP in a nutshell is to provide communication between the client and the server, meaning provide communication on the web. HTTP is the one that handles the loading of pages and is done by continuously sending requests and responses which contain data that's essential for our websites. But as I said, most of us use HTTPS instead. It stands for Hypertext Transform Protocol Secure. The difference is that this protocol, when sending data, actually encrypts the data so that no sensitive information can be grabbed while sending. It uses an SSL, which is something you might be familiar with. That is the thing that enables HTTPS. It's usually purchased for each website when deployed. It gives you a little look at the top left corner of your web page. Let's revisit this model, but this time we'll be focusing on the outgoing request. First off, each outgoing request has a method that defines its type. There are 4 of these, the 4 main we'll be going over. There are still some extra others, but this is more than enough to start with. The first one is a GET request. A GET request is simply for fetching data from the server. We send a GET request whenever we visit a simple website, like YouTube as well. We get the data, HTML, CSS and other stuff from the web server and load the YouTube web page. The second most frequently used one is a POST request. A POST request is used for sending data to the web server. A simple example is registering or logging into a website like YouTube, for example. This way, you send your credentials like email, password, etc. to the server, which then authenticates you by the data you sent. Or if you upload a profile picture to Instagram or simply make a post, those are also POST requests. Next up is the PUT request, which is for updating already existing data on the server. Something that's not displayed here but worth noting is that there is a patch request as well. The difference is that while the PUT request completely overrides the whole dataset, the patch only overrides certain parts, fields of it. Simple example is updating your bio on Instagram. Lastly, there is the delete request, which is quite obvious what it does. It deletes a given dataset from the server. You can send the data that you want to delete, usually the ID of a certain object, and the server gets rid of it, like deleting a post from Instagram. Now that we've covered the basic method types, let's look at what else a request consists of. Basically, a request is constructed of 2 other parts, a header and a body. The header contains metadata that's important for the server to know of. You can see some examples like the content type, which defines the type of data, like application/JSON or text/HTML or text/CSS, stuff like that. Or another commonly used one is the authorization, because that's used for sending out tokens that's needed for logging in and accessing certain features at most platforms. Cookies also reside here, but there are tons of these, so if you need something very specific, you will most likely find documentation about it. Moving on to the body, it has the main data that's sent, mostly in a JSON format. For example, some purchase data with the user ID, price, item and other stuff in it. That's it for requests. Now keep on moving and have a look at what the server answers, because there are some important stuff to cover. With each response from the server, there is a status code included. A status code provides information about what happened, what's the outcome of the processed request, for example, success or errors. Those status codes range from 100 to 500, each 100 representing a different type of status code. The 100s stand for extra information like being processed. The 200s stand for success messages. It's the one you'll always be seeking. The 300s are for redirects or further action needs to be taken. The 400s are client-side errors, meaning something went wrong on the front end. Usually this occurs when you send wrong type of data or trying to access features that need you to be logged in. Lastly, the 500s are internal server errors. They indicate that something went wrong on the backend, the server side. They are more difficult to debug. Let's have a look at the most common status codes you receive. As for success ones, there is 200 OK and 201 OK created. OK created is for something that was created in the database, for example. OK is just a simple success message. As for the redirects, 301 means the URL moved somewhere else and you are redirected to the new URL. Out of the 400s, 400 means bad request. The data sent was wrong, maybe you didn't include all the fields or included the wrong type of data there. 401 is when you're trying to access something that needs authorization. And 404 is not found, you must have encountered this the most often. 500 stands for internal server error, something bad happened on the backend. And of course, the responses also have the body and the header. The difference is that the header contains a slightly different type of metadata. That's it for theory. We can move on to trying these out in practice. Now that we've covered the theoretical basics, let's move on to trying these out in practice. For that, we'll be using something. We'll be including a link for this down in the description, is the Jsonplaceholder. This is basically dummy data where we can test out APIs, meaning we can send requests to this dummy API and we won't actually get back normal data, or not everything will change on their server side, but it's perfect for testing purposes. And I recommend using VS Code for this one because for trying these out, I won't be using Postman, I will rather be using ThunderClient because it's very easy to set up. All you have to do is in VS Code come to extensions and search for ThunderClient. You click install over here and then basically a new tab will get added on the left hand side where you'll be able to make requests using ThunderClient. Now if I close this up, you can see that I've already played around with this a little bit. I can zoom in a little more to make it more visible, and I have some links which I will also be including into the description. These links will be needed to send requests to. We are trying to access the posts and send a GET request. As you can see, you can choose what type of request you'd like to send using ThunderClient to this URL. As for parameters, we can give other query parameters, but for this one I do not wish to do that. I simply want to click send after doing this and see what happens. If you do that, on the bottom side you see that a bunch of data got returned in JSON format. You can see the user ID, and basically it just listed all the data since it's a GET request in an array. Other things to note about ThunderClient is that you can go on to the headers and change them. For example, the accept, or this is more like the content type, you can change it to be application/JSON. You can change the user agent, but it's not necessary, you can just leave it here. You can give authorization if you want to, but we won't be using this for testing out our APIs. So this is a part of the UI where you can really test things out. There is also the body if you want to send from JSON, XML, text, so if you want to type these by hand. Now that we've had a look at a simple request, usually there is a request, a GET request enabled for a singular post as well. By the way, there are not only posts, there are a bunch of other endpoints that you can have a look at, but for this example we'll be using the posts. Here you can type /1 after the end of this URL and then simply click send. The headers stay the same, I haven't changed from the default, and you get back only one set of data with the ID of 1. That's what querying is for. Now that we've covered the most default, the GET requests, we can move on to having a look at the POST requests. And these POST requests, I won't be using any parameters for this one. We will be sending content type of application/JSON. I can also put content type over here, application/JSON. As for the out tab, we won't be using it, but for the body, we are going to insert some data that we'd like to send to the server, because I'd like to create a new type of data. The user ID will be set to 1. The title will be your post title here, and you give the body, which is basically the body of the post. You can write whatever you'd like in here, and if I click send, I get that it was created by the user with the ID 1. It has an ID of 101, and these are the title and the body that I've inserted is also returned in the response to be viewed. By the way, over here, if you click this, it will give you a scroll down where you can have a look at the headers as well. As you see from the response, there is the date at which I've sent this, there is the application/JSON, and also the UTF-8 encoding. There are some other type of headers you can have a look at too. I can also look at the cookies, but no cookies will be saved for just testing this API. There is the results, but no results are given. So basically you will be just moving from the response to the headers if you want to have a look at something like this. And you can see that the status code is 201 created. Over here at the get requests, it was 200 OK because we didn't create anything, we just fetched. But now it's 201 created. If I was to mess up the URL and try to send something, I'd get 404 not found and get back an empty JSON data. In the headers, we wouldn't see too much of a change because that's basically just when did you send it, from which server, stuff like that. So this was a basic post request. Now we can have a look at sending a delete request. I won't be using parameters either. I won't be changing anything in the headers either. The body will also be empty. And if I just send this to the posts/1, because I want only one post to be deleted, that exact post with the ID of 1, I can then click send. And if everything is fine, for the delete response, we get back an empty object or these curly braces. The reason is because there is nothing to really return in the response. Everything was already deleted. So that's it for a simple delete request. And having a look at a put request is also a little different. We won't be using queries this time either. I will still be going for the /1 at the end of the posts. And that's the headers. I won't be changing anything either. Maybe I can change the content type to be application/JSON. In the body, it's important that you put your updated title and updated body. You set your user ID as to authenticate yourself that you are this user that you're sending with, and also simply the ID. If you send this now, you'll be able to see that 200 OK and the updated title with the updated body over here. That's it for ThunderClient. Now just so I can show you that this works also in the network tab, I visited our YouTube page, and here you'll be able to see, if you navigate to the network tab, that there are a bunch of requests that are sent. These are from YouTube, and most of them fails at first, and then you get back. Over here you can have a look at the headers, you can have a look at the payload, meaning what was returned, also preview whatever was returned, also have a look at the cookies, the timing. All this stuff is also available in the developer tools. You can even see that an image is returned. For example, this is in hexacode, but you can preview the image that was sent, and you can see the headers. It has 200 OK as the status with a get request. There is a little bit of CSS returned and all the other stuff. So if you want to practice a little, just go on to one of your favorite websites and open up the network tab. That way you'll be able to see what's going on. So that was it for this basic HTTP crash course. I hope this was helpful and it made sense. If you found value in it, please consider giving us a like, maybe even subscribe. And other than that, I hope to see you in the next one. Happy coding and God bless.